Welcome to Chemistry with Dr. Z. In this video, I'm going to talk about hydrocarbons as part of the organic chemistry content for GCSE. So all organic compounds contain carbon, and most of them are formed by living things. This is why they are called organic compounds, and this is why we call this organic chemistry. Although they are also formed by geological and artificial processes, so we can actually synthesize organic compounds. So what are hydrocarbons? Hydrocarbons are series or classes of compounds, organic compounds that only contain carbon and hydrogen. This is why the name hydrocarbons. There is a wide variety of hydrocarbons. They can vary in length. They can be open chain hydrocarbons with varying lengths. They can be branched chains. They can be formed of rings of carbon atoms or a combination of all of that. Many of the hydrocarbons are found in animals and plants and their fossils. Other hydrocarbons can also be prepared in the laboratory. We use hydrocarbons in every day. So the fuel we use, whether in the vehicles or the fuel we use at home, at the source of heat, all of that comes from hydrocarbons. Also, the plastics, the polymers that you use as plastics, they come from hydrocarbons. So what are the main classes of hydrocarbons that you need to know for your GCSE exam? There are two classes. The first one is the saturated hydrocarbons, and saturated hydrocarbons are represented by alkanes. Alkanes are this class of hydrocarbon compounds which only contain single bond. There is no double bond. They only contain covalent bonds, and all the bonds between the carbons are single bonds. The second class is called unsaturated hydrocarbons, and unsaturated hydrocarbons are represented by the alkenes. And alkenes are this class of compounds which have a double bond uh, between two carbon atoms within their structure. So any compound that has only carbon and hydrogen and has a double bond is called alkene. So before we start talking about the different classes, the alkane and alkenes, we need first to know how to represent the organic molecules. We are all familiar with the empirical formula, and the empirical formula is the simplest whole number ratio of each element in a compound. So if you have a compound, for example, like ethane, that has two carbons and four hydrogen, the empirical formula for this molecule will be CH2 because this is the simplest whole number ratio for all the elements. The second formula is the molecular formula, and we know that molecular formula gives us the actual number of different elements within a compound. So for ethane, it has two carbon, four hydrogen, so molecular formula is C2H4. The third formula is called the general formula, and a general formula is a type of empirical formula that represents the composition of any member of an entire class of compounds. For example, if we have something like alkanes, they have a general formula of CnH2n plus 2. That means whatever the number of carbon atoms in your molecule, the number of hydrogen atom will always be double that number plus 2. So if you have one carbon atom, it's going to be CH4. If you have two carbon atoms, it's C2H6, and so on. Alkenes, on the other hand, have a general formula of CnH2n, which means whatever the number of carbon atoms in your molecule, the number of hydrogen atoms for an alkene will be double that number. Structure formula is a formula that shows the arrangement of the atoms in the molecule of a compound. For example, for ethene, which is one of the alkenes, it's CH2, which means there are carbon atom attached to two hydrogen atoms and then another carbon attached to two hydrogen atom. It doesn't show whether there are single bonds or double bonds. It just shows the arrangements of the atoms. And finally, the displayed formula. The displayed formula is the formula that shows all the connections, all the type of bonds, whether there are single bonds or double bond. And when we talk about the structure of alkane and alkene, we're going to see how we can represent the different members of the alkane and alkenes and using the displayed formula, and how can we show the single and the double bond.